Hi, today's good person to know is John Lowry. He works on App Engine at Google. Now I'm going to be completely honest and say that this presentation went over my head. I didn't get it at all, but that's okay because it's for developers and coders who want to know more about how and why you should build your website using Google's App Engine. Google use App Engine a lot for their own internal apps, and more importantly, when you write your code, you're doing it on top of Google's infrastructure, and I suppose that's going to be good, right? John pretty much knows everything there is to know about App Engine, and he has been dealing with customer queries for so long that he's able to identify the most common problems that they encounter. His presentation covers data storage, that it's scalable, partitioned into tablet servers and replicated across all data centers. He also talks about consistency and that it's very cheap to use. He speaks of Megastore, that it gives the ability to do ACID transactions, and that there's also a white paper for those of you that need extra assistance. It has a built-in Memcache, so that's one less thing that you need to worry about. He also talks about loading requests and latency. John says Snapchat uses App Engine and they've done phenomenally well, and there's no reason why that can't be used. So I hope you enjoy this video, and thanks for watching.
If you're using App Engine, you really are writing code like a Googler, because we use App Engine for a lot of our internal apps. We are both internal and external, but you're also writing your code on top of Google's technical infrastructure, using the same databases, the same network, the same load balancing that every other Google service uses. It's the underlying storage for the data store is Bigtable, and that's the well-known database that Google provides. It's a very simple key value store. The keys are ordered. The data is scalable, so the data is partitioned across tablet servers. And if you have more data, then you just add a tablet server. It's also highly available. The data is replicated across data centers. It's replicated within a data center on a distributed file system, and it's also replicated to another data center. So if there's a fiber cut, one whole data center goes down, your application will still keep running. App Engine actually uses a layer on top of Bigtable called Megastore. It's a library, and the reason we do that is because the data store is a very bare bones user interface for an application programmer. So what Megastore provides is it provides the ability to do ACID transactions. To get secondary indexes with Megastore, so you can sort your rows by different dimensions other than the primary key. And again, there's a white paper which describes the entire architecture, which you should probably read if you are really getting deeply into it. The things that I see and support, this is probably the most important thing to know about the data store. Consistency means you're going to be seeing the most up-to-date version of your data, not an out-of-date version of your data from a previous transaction. There are plenty of other data store design patterns, and I'll just run through them quickly. And if you're moving from a SQL database to a NoSQL database, you'll have to get used to this. I mean, hopefully you're convinced that this is a good way to go because of the availability and scalability, and that the trade-off of consistency is well worth it. Storage is cheap. Before this talk, I looked up the cost of storing 1 terabyte on App Engine, and it's $184 a month. I don't know, what's that, £120 a month or something like that. If you're putting that in an Oracle database, how much would that cost? A terabyte of Oracle or a terabyte of MySQL or Postgres? It's going to cost a lot more, particularly if you're trying to replicate it across data centers. Is it even possible? You can denormalize your data model to avoid the cost of joins. So if I have an account record and a user record, just put them together in the same kind, the same row, and then you'll just do one data store query, get both sets of data, rather than two queries in serial in a slip, leading to higher latency. Because of Bigtable's great scalability and availability, we can offer an SLA of no more than 4 or 5 minute downtime periods per month for the data store. And App Engine also provides a built-in Memcache API. And Memcache there's lots of different caching solutions out there. Memcache is probably the industry standard. The guys who wrote Memcache now work for Google. And you don't have to do anything extra with App Engine. You've got the API there ready to use. You just call it. And it's usually less than a millisecond to get your data back. So if you're requesting the same data all the time from the data store, you just put it in Memcache. If you use one of our built-in libraries like NDB, it handles the Memcache behind the scenes. So as a programmer, you don't even think about, do I need to cache this object in Memcache? Do I need to make the cache dirty, invalidate the cache, or anything like that? The library just takes care of it automatically. I mentioned some best practices here that, things to be aware of that I see, customers not getting right a lot of the time. Don't depend on tasks executing immediately after creation. A lot of people think of task queues as a real-time system, and most of the time they are real-time. Everything works normally, but they weren't designed to be completely fault-tolerant. So occasionally there'll be a little hiccup, and there'll be a 10-minute delay in your tasks, or lower throughput, or something like that. And you should design your application to be aware of things like that, and not to have a problem if you're expecting a task to happen exactly the moment that you said it should happen. On App Engine, when you're using task queues, you can use the fact that task queues will retry automatically and divide your job into lots of small steps. And if one of these steps fails, it will just get retried. Even better than writing your own set of tasks is to use one of our libraries to chain your tasks together. The pipeline API is for workflow, for chaining tasks together. And the MapReduce API is a system for running tasks in parallel. Performance tuning. Here's another area that you have to be aware of for app engines. You need to have some idle instances so that if you get a spike in requests, let's say you get some publicity and lots of people come to your site, you have higher number of requests per second. If you have too few idle instances, then requests will sit and they'll wait on a pending queue. And if you have too many idle instances, then you have to pay the cost of the computing time. So you want to get that right. There's just two buttons to twiddle. The minimum idle, which are resident instances that sit there waiting, and they're unused unless all your dynamic instances. The dynamic instances are the ones that scale up and down with the scheduler. And the max idle, which is the number, you tell Google how many idle instances am I willing to pay for. A loading request is when you don't have any idle instances available, and a request comes in, and the App Engine scheduler decides that it's not going to queue up your request. Maybe there's too many requests already queued. It's going to have to start a new instance and wait for the cost of the new instances of your application, the cost of an instance starting up. If you put your performance settings very aggressively to reduce costs, you'll end up with more loading requests. That's the trade-off that you can decide. And then the other important thing is to try and minimize the time spent in a loading request so that your instance starts up very quickly. What libraries does it start up? Does it run any code? Is it initializes? Most applications, the latency is fine, and you can run a load test. It's very cheap. You can run a load test for 5 minutes or something like that. It costs you virtually nothing, and you'll see what the latency is. So I wanted to talk a bit more about the things you get just by running on App Engine from Google's infrastructure. You get Google front ends to protect you against denial of service, bad requests. These are all things, if you're writing a scalable app, in the past you have to try and figure out how to do them yourself, and it's very complex. I wanted to mention one startup that is on App Engine, Snapchat, little messages that persist for 20 seconds or something. 150 million snaps per day. Their last funding round was an 800 million valuation. The back end, obviously they use a mobile plant, their back end is built on App Engine. And publicly they have 17 employees. So I can tell you, there's almost nobody working on the App Engine side. So you can really scale to a very big business, very fast, with very few people. If you have a startup and you want to use App Engine, we're going to give you a $1,000 credit. And the details are at this URL, and there's a code that you should use.